Questions 1 through 10 on the 2006 Grade 10 AMC 10A. Sandwiches at Joe's Fast Food cost $3 each and sodas cost $2 each. How many dollars will it cost to purchase 5 sandwiches and 8 sodas? So 5 sandwiches at $3 a piece plus 8 sodas at $2 a piece is $15 plus $16, and that equals 31. So number 1, the answer is A. Define x symbol y as x to the power 3 minus y. What is this expression? So first, let's just do what's there in the brackets. So that's x, or h rather, symbol h, and that, according to this definition, is going to be h to the power of 3 minus h. Now let's bring in the entire expression, which is h symbol the brackets, but in the brackets it's going to be h to the power of 3 minus h, and that, according to our definition, is going to be h to the power of 3 minus what's in the brackets. And this simplifies to h to the power of 3 minus h to the power of 3 plus h, and that is just h. So number 2, the answer is C. The ratio of Mary's age to Alice's age is 3 to 5. Alice is 30. How many years old is Mary? So Mary divided by Alice is 3 over 5. They tell you that Alice is 30, and then we have to figure out Mary's age. So the ratio is 3 over 5. Cross multiply and you get 5m is equal to 90, and therefore m is equal to 90 divided by 5, which is 18. So number 3, the answer is B. A digital watch displays hours and minutes with AM and PM. What is the largest possible sum of the digits in the display? So we've got a certain number of hours and we have a certain number of minutes. Now the minutes, of course, the largest in terms of number is 59, right? Because nothing larger than that is ever displayed. There's no such thing as 60 minutes. It'll just show 00 because that's the next hour. And then in terms of the hours, if it's a AM PM clock, then it's just going to show 1, 2, all the way up until 12, like that. So in terms of the largest digits, 09 would be the largest. And this is going to give us the largest possible sum of the digits, which is going to be 9 plus 5 plus 9, which is 23. So number 4, the answer is E. Doug and Dave share a pizza with 8 equally sized slices. Doug wanted a plain pizza, but Dave wanted anchovies on half of the pizza. The cost of the plain pizza was $8, and there was an additional cost of $2 for putting anchovies on one half. Dave ate all the slices of anchovy pizza and one plain slice. Doug ate the remainder. Each of them paid for what he had eaten. How many more dollars did Dave pay than Doug? Well, Dave is the one who wants the anchovies, so first he has to pay the $2 for the anchovies. And then he eats half of the pizza because he eats all the slices that have the anchovies. That's half the pizza. And he eats one additional slice. So what that means is that he ate 5 of the 8 slices. And 5 over 8 multiplied by the cost of the pizza, which is $8. So that looks like 2 plus 5, which is $7. That's how much Dave paid. For Doug, he's going to pay 3 over 8 because he only ate 3 slices times the cost of the pizza, which is $8, and that's $3. So Doug is actually D-O-U-G. And then now we have to compare the two costs. Dave paid 7, Doug paid 3. So Dave paid $4 more then Doug. So the answer to number 5 is D. What non-zero real value for x satisfies 7x to the 14 is 14x to the 7? There's several ways of doing this. Let's see here. I think the simplest way might be just to look at the exponents and get a comparison. Well, 14 is very similar to 7 in this sense that it's a multiple. So what I can do is I can write 7x to the power of 2 all to the power of 7 is equal to 14x to the power of 7, like that. And since the exponents are the same, I can get rid of them and just concentrate on what is left. So that means 7x all squared is equal to 14x. Correct? So that means 49x squared is equal to 14x. I can divide both sides by x, and that leaves me with 49x is equal to 14, and therefore x is equal to 14 over 49. And let's see here, if you divide both sides, both the top and bottom by 7, that will leave me with 2 over 7. So number 6, the answer is B. The 8 by 18 rectangle ABCD is cut into 2 congruent hexagons as shown, in such a way that the 2 hexagons can be repositioned without overlap to form a square. What is y? So this is approximately how you can reposition them to form a square. And when you do, of course, like all squares, the sides have to have equal length. Now they tell you that this is 8 and this is 18. So that means from here to here is 8. Now, when you reposition this, for this to fit right here, it would have to equal. So what that basically means is that this side has to be the same as that. So each of those has to be 4. So if this is 4, that must be 4 for it to match. And that's the only way it can fit exactly. Okay, well that helps us because that means that this guy, when you repositioned it, comes here. So that is 4. So that means this whole side is 12. So that means that this whole side must also be 12 since they tell you it's a square. And then in a very similar way, when you repositioned it, this had to sit on top of this. So they had to be equal. And what that essentially means is that this has to be the same as this right here. And this has to fit on top of that. So if this is y right here, this distance also has to be y. And when you repositioned it, the y's basically became that distance and that distance. Okay? So that means 2y is equal to 12, and therefore y is equal to 6. So number 7, the answer is A. A parabola with the equation y is equal to x squared plus bx plus c passes through the points 2, 3, and 4, 3. What is c? So we substitute those points in to get two equations. So that means 3 is equal to 4 plus 2b plus c. And 3 is equal to 16 plus 4b plus c. And these two equations are what we're going to use to solve for c. Let's see here. If you take these two equations and subtract them from each other, it would give you 0 is equal to 12 plus 2b. The c's cancel. And that basically means that b is equal to minus 6. And then substitute that into either of these, and that helps you solve for c. So for example, it would give you 3 is equal to 16. 4 times minus 6 is minus 24 plus c. So that means we got 3, and then on that side it's minus 8, so you bring it over, it's plus 8, and therefore c is equal to 11. So number 8, the answer is E. How many sets of 2 or more consecutive positive integers have a sum of 15? Well, let's see. if there's two positive consecutive integers, it would be x plus 1, and that would be 15. That means 2x plus 1 is equal to 15. 2x is equal to 14, and therefore x is 7. So that means those two would be 7 and 8. That's one set. Let's see if we can get any more sets. How about if we have three consecutive positive integers? That would give me x plus 1, and x plus 2. This is 3x plus 3 is equal to 15. 3x is equal to 12, and therefore x is equal to 4. So that set is 4, 5, and 6. All right, let's try 4 consecutive positive integers. That would give me the following. We've got 4x plus 6 is equal to 15. 4x is therefore equal to 9. But at this point, x becomes 9 over 4, and that's not an integer. So I can't use that. All right, no problem. Let's see if I can get any more. How about if I have 5 consecutive integers? This gives me 5x plus 10 is equal to 15. And 5x is therefore equal to 5, and x is equal to 1. So that would mean that set is 1, 2, 3, 4, 5. And then any other similar equation would give me a value of x that's less than 1, and that would therefore not be a positive integer. So how many sets did I get? I got 1, 2, 3. So number 9, the answer is C. For how many real values of x is this expression an integer? So we've got 120 minus the square root of x, all under the square root sign. That has to be some integer. And the only way that's going to be an integer is if what is under the radical sign is a perfect square. So what's under here has to be a perfect square. So it has to be either 0 or 1 or 4, 16, 9, 16, 25, and so on. Now our question is, how far can we go? 49 and dot, 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 right? Well, if we want to know our extreme limit, we have to figure out what will happen in certain conditions. So for example, let's say I made this as small as possible, which is 0, right? Because it's got to be positive or 0. Square root of x is either 0 or it's greater than 0. If it's 0, then this becomes 120. So all of our perfect squares have to be less than 120. So I can make this list going all the way up to 120, and that's it. Because if I use 121, that's not going to work. So that's it. And let's verify a couple of these. Let's say what's under the square root sign is equal to 0. So 120 minus the square root of x is equal to 0. That means that 120 is equal to the square root of x, and therefore x is 120 squared. Okay, that works. How about if it's 100? What's under the square root sign? 120 minus the square root of x is equal to 100. So that means that the square root of x is equal to 20, and therefore x is equal to 20 squared, which is 400. Correct? So in a similar way, all of these will check out. So how many did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So number 10, the answer is E.